Good morning, students. As we have started dual nature of matter, in that we have studied photoelectric effect. Here, today we'll study Einstein photoelectric equation. So, as per Planck's quantum theory, these light radiations consist of small packets of energy. Those packets are known as quanta. And one such quantum of light radiation, this is called photon, which travel with the speed of light. So we will take what will be the energy of photon. This energy is given by h into nu, where this h is Planck's constant and nu frequency of light radiation. So Einstein assumed that one photoelectron is ejected from a metal surface if one photon of suitable frequency fall on the surface. नहीं, अगर हम कहते हैं कि लाइट इंटेंसिटी फॉल करती है तो जितने फोटोन्स यहाँ इंसिडेंट होते हैं उतने ही फोटो इलेक्ट्रॉन्स एमिट आउट होते हैं. सो नाउ कंसीडर अ फोटोन ऑफ फ्रीक्वेंसी न्यू, यानी इंसिडेंट photon having frequency nu, it is incident on this photosensitive metal. So energy of incident photon, that is h nu, it is spent in two ways. एनर्जी कैसे यूटिलाइज हुई? देखिए, जैसे ही ये फोटोन यहाँ स्ट्राइक किया, यानी एक पार्ट इस एनर्जी का यूटिलाइज होगा टू इम्पार्ट एन एनर्जी so that it will be liberated out. That means a part of the given energy is used in ejecting the electron from the metal surface. That will be equal to work function. Work function, why? Because this is equal to the minimum energy required to take out the electron from the surface. That is depending upon threshold frequency. And what will be the role of the remaining part of energy? Remaining part of energy that will be used in imparting kinetic energy. So here another part of it will be used in imparting kinetic energy, where kinetic energy that will be given by half mv square, the maximum, that is maximum velocity of emitted photoelectrons. So here h nu equal to phi naught. Phi naught क्या है? h nu naught. h nu naught plus half mv square. So it means a part of this energy is used to remove the electron from the surface, and then remaining energy is used to impart kinetic energy. So what will be the kinetic energy? This kinetic energy will be equal to half mv square equal to h nu minus h nu naught. That means it is h nu minus nu naught. So this is basically the equation. This equation is called Einstein photoelectric equation. So as we have already explained laws of photoelectric effect, here Einstein by this rule will explain all the laws. So now from Einstein photoelectric equation, that is kinetic energy is h nu minus nu naught, we will explain the laws of photoelectric effect. As one incident photon is ejecting out one photoelectron from the metal surface, what does it mean? That the number of photoelectrons emitted per second depending upon the number of photons incident on the surface per second, which again depend upon intensity of incident radiation. So what is the relation? Basically that whatever be the number of photoelectrons emitted, it is depending upon intensity. यही law था first हमारा photoelectric emission का, that when photon is incident over the surface, then the electron is emitted out. More will be the number of photons, more will be the number of electrons ejected out. It means अगर हम incident radiation की intensity को बढ़ा देते हैं तो number of photoelectrons भी increase हो जाते हैं. So you can say the photoelectrons emitted out is directly proportional to intensity, or you can say photoelectric current is directly proportional to intensity of radiation. This is first law. we are explaining the same photoelectric effect but under this equation. Now, second law, if this incident frequency is less than threshold frequency. अब देखिए मैथमेटिकली देखिए, अगर न्यू लेस हो जाए न्यू नॉट से तो क्या होगा, काइनेटिक एनर्जी इन दैट पर्टिकुलर केस विल बी नेगेटिव. So can kinetic energy, negative kinetic energy is possible? Never. It can never be possible. So it means in that case photoelectric emission does not takes place. For incident radiation whose frequency is below threshold frequency. So this is second law of photoelectric emission. यानी अगर incident frequency threshold frequency से less है, then emission of photoelectrons will not be taking place. Why? Because in that case kinetic energy will become negative. Third law. So for emission of photoelectron to take place, incident frequency must be greater than this threshold frequency. And as we are observing from this equation that this maximum kinetic energy, it is proportional to the frequency. So if the intensity of incident radiation is increased, अगर हम intensity of radiation को increase करते हैं तो क्या होगा, number of photons will increase. Number of electrons, photoelectrons will increase, but energy of the photon, that will not change. It will remain same. So we can say that kinetic energy is depending upon frequency, but it is independent of intensity of incident light. Now the fourth law. The phenomena of photoelectric emission, it is an effect of elastic collision between फोटोन एंड इलेक्ट्रॉन. देखिए अगर इस मेटल सरफेस पे एक फोटोन इंसिडेंट करता है तो सरफेस पे जो इलेक्ट्रॉन है ये इससे कोलाइड होता है, तो सबसे पहले कॉलिजन की वजह से नाउ देयर विल बी, व्हाट विल हैपन, देयर विल बी एब्जॉर्प्शन ऑफ एनर्जी. यानी जो फोटोन एनर्जी स्ट्राइक हो रही है वहाँ से वो इलेक्ट्रॉन कुछ एनर्जी को एब्जॉर्ब करेगा, एंड आफ्टर एब्जॉर्प्शन ऑफ एनर्जी देन इट विल मूव आउट फ्रॉम द सरफेस. So you can say absorption of energy by electron from incident photon is an event which involve transfer of energy without any time lag. तभी हमने कहा था that it is an instantaneous process. यानी जैसे ही फोटोन इंसिडेंट होता है इमीडिएटली ये एनर्जी इलेक्ट्रॉन को ट्रांसफर होती है, विदाउट एनी टाइम लैग इट विल इजेक्ट आउट फ्रॉम द सरफेस. So these are the four laws of photoelectric emission which we have explained on the basis of this Einstein photoelectric equation. So now what kind of question can be there? Explain photoelectric emission on the basis of Einstein's predictions, or explain or derive Einstein photoelectric equation and explain photoelectric effect on its basis. So now, after studying this Einstein photoelectric equation, next we will find relationship between this cutoff potential, frequency of incident photon and threshold frequency. Now, as we know that kinetic energy is h nu minus work function, where this you can write it like this also, or both are the same factors, because work function having value h nu naught. Now from here, as we know that kinetic energy, this is also equal to EV naught. V naught, that is cutoff potential, E is the charge. So from this equation, h nu minus nu naught. So if we want to express it in terms of wavelength, तो nu क्या हो जाएगा, c by lambda. Nu naught will also be c by lambda naught. So EV naught or kinetic energy equal to h c by lambda minus c by lambda naught. This is h c 1 by lambda minus 1 by lambda naught. So this is the relationship. Sometimes in numericals you can use it directly. So there are different forms of this equation. Now we will determine Planck's constant and work function of a metal by this graphical representation. As if we plot graph between stopping potential and frequency, graph will be like this, where this is the threshold frequency below which no emission of electron takes place. Let this angle is theta. And when we are producing it in the backward direction, that is intercept on this vertical axis, this will be phi naught upon E, along with negative sign, because it is the potential, that is negative potential. So from Einstein Photoelectric Equation, kinetic energy is h nu minus phi naught, which can further be written as EV naught h nu minus phi naught. अब अगर देखिए हम यहाँ से बेसिकली इस ग्राफ के कोरेस्पॉन्डिंग अगर हम इसका स्लोप निकालना चाहें तो स्लोप किस किस के बीच में है, पोटेंशियल एंड फ्रीक्वेंसी. तो लेट वी just take this E on the right side. So V naught equal to h upon E nu minus phi naught upon E. So this is equation. Now let me compare it with straight line equation. So what we are getting with slope of this graph, or you can say tangent theta, this is represented by here. अगर आप इसे compare करते हैं, this is y V naught, this is x nu, तो slope क्या हो गया, this is h upon E. And from the graph you can see that from this graph, if this is theta angle, if you consider 2 points on the graph, correspondingly this will be del V naught and this is del nu naught. तो टेंजेंट थीटा क्या हो जाएगा यहाँ से, डेल वी नॉट अपॉन डेल न्यू नॉट. तो यहाँ हम ले सकते हैं डेल वी नॉट अपॉन डेल न्यू नॉट. सो दिस इज गिविंग यू द स्लोप. And from this slope, if we want to calculate the value of this h, that is a Planck's constant, तो h क्या हो जाएगा, E into tangent theta. That is E into slope of V naught with nu. So this is how we can calculate this Planck's constant value. And intercept on potential axis. तो देखिए in the figure, intercept on this potential axis, this is OP. अब OP, this is equal to this minus phi naught upon E. The intercept on potential axis will be minus phi naught upon E. After this, let me draw few graphs. Already we have drawn the graphs related to photoelectric effect. Now further, if we plot graph between potential or kinetic energy with frequency, this will be a graph like this, where its intercept on vertical axis is minus phi naught upon E. This is nu naught. If we are taking different metals, so correspondingly the same graph will be having different threshold frequencies. मान लो हमने अलग अलग मटेरियल्स लिए हैं तो तीनों मटेरियल्स की थ्रेशोल्ड फ्रीक्वेंसी भी अलग अलग होगी. So if we have been asked to plot graph between frequency and maximum kinetic energy, the same graph, because kinetic energy is E into nu naught, so graph of kinetic energy or of the potential with frequency will be same. Next, when we plot frequency and photoelectric current, so this graph will be like this. सबसे पहले तो करंट एमिट नहीं होगा जब तक कि कुछ मिनिमम फ्रीक्वेंसी नहीं अप्लाई होगी, and after this current will be constant, so it is independent of frequency. And if the graphical representation has to be done with respect to, that is intensity and stopping potential, as we know that kinetic energy and stopping potential is independent of intensity, so graphical representation will be constant like this. Whatever be the intensity, stopping potential will not change, kinetic energy will not change. So either stopping potential or kinetic energy with intensity, अगर यहाँ kinetic energy भी दें तो भी ये graph straight line होगा. Now if we plot graph between photoelectric current and time, so it will be like this. Initially with the time it increases and after that it saturates. So this time is 10 raised to the power minus 9 second. So here we have studied all the graphs. Now next we will discuss particle nature of light. So for that we will study some of the characteristics of photons. So let's see. So let me read the points. So what are the characteristics of photons? In interaction of radiation with matter, radiation behave as if it is made up of particles like photons. So these are some characteristic points. I will explain it one by one. So radiation जब matter के साथ interact करती है तो ऐसा it just gives an indication that it is made of photons. And whatever photon we are taking, it is having certain energy and momentum. Energy will be h nu and momentum will be h into nu upon c, mass into velocity, where h is the Planck's constant. All photons of a particular frequency have same energy and same momentum. As we know that for a particular frequency energy is h nu, so it will be same, and for the same frequency momentum will also be same. Now by increasing the intensity of radiation of given frequency on metal surface, there is only increase in number of photons incident on the surface, while each photon has the same energy. That is, photon energy is independent of radiation of इंटेंसिटी ऑफ रेडिएशन. देखिए ये कॉमन पॉइंट है जो हम बार बार यूज़ कर रहे हैं कि एनर्जी ऑफ द फोटोन इज इंडिपेंडेंट ऑफ इंटेंसिटी. All the photons emitted from the surface travel through space with the same speed. Then frequency of photons gives radiation a definite energy which does not change. That means which remain to be constant, because E equal to h nu when photon travel through different media. So frequency of photons that will not change when changing of medium. That is, frequency of photon remains same in different medium. Next, velocity of photon in different medium is different. Next point. As this is quite different, so understand it carefully. Rest mass of photon is 0. What do you mean by rest mass? See, normal condition में जो mass हम use करते हैं, that is rest mass. But when speed of light, speed of the particle become comparable to speed of light, so as per relation m equal to m naught by under root of 1 minus v square by c square. So at one particular chance, then v become equal to c. तो क्या होगा? ये factor in this will be 1 minus 1 0. That means mass, ये m naught क्या हो जाएगा? 0. So rest mass of a photon is 0. Next, photons are not deflected by electric and magnetic field. That is, photons are neutral. In photon particle collision, यानी photon जब किसी surface पे strike करता है और electron emit out होता है, so in that photon particle collision, energy and momentum will remain conserved. However, number of photons may not be conserved. Energy will remain to be conserved. This is the main point. In n photons, each of frequency which are emitted per second from a source. So power of light radiation will be energy per unit time. This is per unit energy per unit time. So correspondingly, if n photons are there, तो energy हो गया, energy emitted per second की बात हो रही है, तो number of photons multiplied by energy. ये relation हम numericals में भी कई जगह use करेंगे when we have to calculate number of photons. So these are some characteristic points, characteristic features of photons. Now, next important point that we have to discuss, that is, we explain this photoelectric effect, but wave theory is unable to explain different points which we have studied in photoelectric effect. So next point that we are discussing, failure of wave theory of light to explain this photoelectric effect. So what about wave theory? As per wave theory, energy carried by a beam of light is measured in terms of intensity of light. When waves of light of higher intensity fall on a metal surface, it will impart more energy to इलेक्ट्रॉन इन द मैटर। देखिए वेव थियरी क्या कहती है कि अगर हम इंटेंसिटी को बढ़ा देते हैं तो इसके कॉरेस्पॉन्डिंग इलेक्ट्रॉन्स को ज़्यादा एनर्जी मिल जाती है। सो ड्यू टू इट काइनेटिक एनर्जी ऑफ इजेक्टेड इलेक्ट्रॉन विल इंक्रीज। So wave theory के according kinetic energy is depending upon intensity of light, but this is not in according to experimental discussion of photoelectric effect, as maximum kinetic energy of ejected photoelectron is independent of intensity of incident radiation. So that's why this postulate, this point is not explained by wave theory. Why? Because in that what was considered कि जैसे ही intensity of incident radiation की increase होती है तो उसकी corresponding जो electrons की kinetic energy बढ़ जाती है, that will be increasing. So that is a contradiction point. So wave theory is unable to explain this important point. Next point, wave theory says that photoelectric emission is taking place for all the frequencies, irrespective of the point that there should be some minimum frequency. So this is a bit contrast between the experimental conclusions. See here, according to wave theory of light, photoelectric emission is possible from a metal surface by all the frequencies. It means photoelectric emission will take place even if frequency of incident light is less than threshold frequency. यानी अगर जितनी minimum frequency surface से इलेक्ट्रॉन को निकालने के लिए चाहिए, अगर उससे कम भी एनर्जी दे रहे हैं तो इलेक्ट्रॉन निकल आएगा, वो सरफेस से डिटैच हो जाएगा. But experimentally no photoelectric emission will take place from a metal surface if frequency of incident light is less than threshold frequency. Next, when wave of light fall on a metal surface, energy of wave of photon will not go to a particular electron in the metal. यानी हम क्या कहते हैं कि जो एनर्जी किसी सरफेस पे पॉइंट आउट हुई उस पॉइंट से फोटो इलेक्ट्रॉन एमिट आउट हो गया, यानी टाइम डिफरेंस ऑफ एब्जॉर्प्शन ऑफ एनर्जी एंड इजेक्शन ऑफ इलेक्ट्रॉन इज़ वेरी लेस. लेकिन ये क्या कह रहे हैं कि वेव थ्योरी के अकॉर्डिंग कि जो लाइट इंटेंसिटी सरफेस पे फॉल की, अब उसकी कॉरस्पॉन्डिंग दैट विल नॉट गो टू अ पर्टिकुलर इलेक्ट्रॉन बट इट विल गेट डिस्ट्रीब्यूटेड टू ऑल द इलेक्ट्रॉन्स प्रेजेंट इन द इल्यूमिनेटेड पोर्शन. यानी अगर हमारा ये इल्यूमिनेटेड पोर्शन है तो यहाँ पे एक इलेक्ट्रॉन को एनर्जी ना दे कि ये एनर्जी डिस्ट्रीब्यूट हो जाएगी. सो अब उससे क्या होगा, इट विल टेक सम टाइम टू एक्यूमुलेट एनर्जी, यानी उस इलेक्ट्रॉन को जितनी एनर्जी चाहिए उसमें कुछ टाइम लगेगा क्योंकि वो एनर्जी तो यहाँ डिस्ट्रीब्यूट होने लग गई. सो हेंस इलेक्ट्रॉन एमिशन विल नॉट टेक्स प्लेस इमीडिएटली. दिस इज अगेन अगेंस्ट द एमिशन ऑफ फोटो इलेक्ट्रॉन्स because as experimentally it is an instantaneous process. जैसे ही एक फोटोन इंसिडेंट करता है सरफेस पे, इलेक्ट्रॉन को सफिशिएंट एनर्जी मिल जाती है एंड दैट इट इज moving out. So this is again in contradiction with that of the third postulate of photoelectric emission. So here we have explained what are the failure points. That first point, that kinetic energy of incident radiation that is independent of intensity, but wave theory says that kinetic energy depend upon intensity. दूसरा पॉइंट क्या कहा वेव थियोरी ने कि इजेक्शन ऑफ इलेक्ट्रॉन विल टेक्स प्लेस फॉर ऑल द पॉसिबल फ्रीक्वेंसी. देयर इज नो कंडीशन ऑफ थ्रेशोल्ड फ्रीक्वेंसी बट एक्सपेरिमेंटली इट कैन नॉट बी पॉसिबल. एंड थर्ड पॉइंट कि इलेक्ट्रॉन जब फोटोन्स अगर किसी सरफेस पे फॉल करता है तो उसके करस्पॉन्डिंग वो एनर्जी उस सरफेस पे डिस्ट्रीब्यूट हो जाएगी, जिससे कि एक पर्टिकुलर इलेक्ट्रॉन को निकलने के लिए उतनी एनर्जी इमीडिएटली नहीं मिलती है. So it will take some time. So all these points cannot be explained by wave theory. So there can be short note that how can you explain that wave theory cannot explain this photoelectric effect. So then you have to give this explanation.